Hello and welcome back to Valley Network's webcast series. My name is Ilan and today we're going to talk about front running, the same attack that came from the traditional stock market and is relevant also for the blockchain. We will see what damage can it cause, how can we detect it, and how can we prevent our code containing this issue by simply designing it better. So first of all, reordering attack or front running is when someone is seeing a transaction being sent to the blockchain and then he sends another transaction to go inside the block before the original transaction in a way that will leverage his profit. For example, if somebody solves some kind of puzzle and he might get a prize for that, he will send the solution as a transaction to the blockchain. Then a malicious user will see the solution and will send also the solution to the same contract but with higher fees. That's why his transaction will be inserted before and he will get the prize. The same goes for stocks in the traditional world. When somebody is about to buy a stock for, let's say, $100, but the stock price right now is $98. So somebody can see this transaction and buy the same amount of stocks for the price of $99, and then he will immediately sell those stocks to the one that sent the transaction for $100 per stock. And that's how he can profit for $1 per stock without the risk, because he knows that already someone is about to buy it. So let's see how a contract on Ethereum might look like when containing such vulnerability.
So now, as you can see, we're using Solidity with compiler version 0.4.18. We have the contract called Bounty when somebody is advertising a puzzle, and when someone knows the solution, he would claim the reward. You can see the bounty creating the puzzle, and we can see the claim where we're checking on the solution, and if it fits the puzzle, we will send him the balance of this contract. How can this be exploited? So let's think, for example, that someone have found the solution for the puzzle. He sends the solution and he's waiting for his prize to be claimed. But then a malicious user can see the transactions since everything is transparent on the blockchain, and he will send the same transaction as well, but with higher gas fees. And as you all know, the miners will first process transaction with higher gas fees, and then he will reclaim the prize. And when the original user will get to his turn and his transaction will be processed, the price is already reclaimed. So that's how this can be attacked. But how can we prevent it? So there are two ways to prevent it. One is more naive and is just putting some statement that will require the gas price to be lower than some standard. So no one can put a significantly higher gas price and get his transaction to be reordered and be the first one. And the other solution is with code, with a design pattern called blinded commitments or commit and reveal. And that's when someone who knows the solution will first commit a solution, then after several blocks, for example after 60 blocks, he will reveal the solution itself. So if someone will steal the solution, he will not be able to send this transaction and be reordered, because this transaction will be hashed with the message sender. So only the original person who sent the commit first will be able to get the price. And that's how we can prevent this occasion when someone steals the information from the solution, by first committing that we have a solution with some hash and then showing the solution with some salt and the message sender.
So now we all know how to prevent our smart contracts from containing such vulnerability as front running. Thank you very much for listening today. I'll invite you to come to our website valid.network to learn more about smart contract security. I'll see you guys in the next time with another smart contract vulnerability. Bye bye!